Welcome back, everyone. Today, we're going to talk about microcontrollers. So, we're not going to talk about the entire subject or the entire field, but we're going to talk about a specific subtopic which comes under microcontrollers. So, let's further move on. So, before moving on to the subtopic that I was talking about, let us know what microcontroller is. A microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. It includes a processor core, memory, programmable input-output peripherals. So basically, it's like a mini computer which is programmed in an embedded system, and its purpose is for just a specific um, function, or it has just a specific purpose. These are the key components of the microcontroller: timers and counters, input-output ports, ADC, DAC, which means analog to digital converter, and vice versa. Jump instructions. So this is the subtopic we're going to discuss about today. So in context to the 8051 microcontroller, so whatever we're going to talk about, like the programming part, it's related to the 8051 microcontroller. So a jump instruction is used to alter the normal sequential flow of execution in a program by transferring control to a different part of the program. This is essential for implementing loops, conditional execution, and functional calls. So while programming in a 8051 microcontroller, and in case you need a loop or a conditional statement in your program or instructions, you need to specify the jump, or it is necessary to use the jump. So there are two types of jump statement and jump instructions. One is conditional and the other one is unconditional. Uh, the conditional jump is a jump in which control is transferred to the target location if it meets the required condition. And the unconditional jump is a jump in which control is transferred unconditionally to the target location. There are two types of unconditional jumps: long jump and short jump. So we'll first go through the types of unconditional jumps. This is JMP, but we call it as jump, which is easier and so as jump. So that's JMP, I know, but it's easy to call it as jump. So as jump, the SM instruction in the 8051 microcontroller is used to make a relative jump within a range of -128 to 127 bytes from the address following the sjump instruction. It is an unconditional jump, meaning it always transfers control to the specified target address without checking any conditions or flags. So flags or status flags are used or are the results of an instruction or an operation. So once an instruction or an operation is executed, the flags are like a default or an output from the microcontroller sides, which defines the status of the instruction. So whatever the status of the flags might be, the SM will transfer its control to the specified target address. So you can see that we have used sjump loop, which is an unconditional short jump to loop, and we have used another one over here as sjump end. Here, whenever you use end, it means that the part of the program or the assembler or the assembler program consider the program as the end. After the end, the assembler will ignore the instruction paths. So you can see that we have used two places. Let's go to the next slide, or the next kind of jump instruction, which is ljump, long jump instruction. So the long jump instruction in 8051 microcontroller is used to jump to any location within the entire 64 KB code space, allowing for absolute addressing. This is useful for jumping to different parts of the program based on specific conditions, such as the status flags. In sjump, we saw that on a condition, we give a condition, and if the condition is satisfied, it jumps to the specified location. But in long, and it has a range which is from minus 127 to 120 plus 127. But this can jump to a very long memory space, which is of 64 KB. So you can see the example code over here. We've used L jump, no carry. So no carry flag is not set, and L jump end, a jump to the end of the program. So if this is a condition where if it reaches to this part of the instruction, it jumps to the end of the program. And you can see that we have used S jump too. So JZ, the jump, JZ is jump F0. Instruction in the 8051 microcontroller checks if the accumulator A is 0. If the accumulator is 0, it transfers control to the specified address or label. This instruction is useful for conditional branching based on the value of the accumulator. So JZ instruction format, syntax, and JZ label. So we've used JZ end over here. So when you've not for a label or in programming terms of microcontroller, we call it as label, but in general terms like a variable. So if a variable has a value of 0, then you can see that it transfers control to the specified address or the label given to it. So this is just a detailed instruction or a detailed information of how the JZ works. See, at the first iteration, A is equal to 5 and decrements A equal to 4. Accumulator is not 0, so it jumps to loop again. Then again, it is 3 and not equal to 0, so it jumps to loop again till it comes to 1. So when A is equal to 1 at fifth iteration and A is equal and it decrements to 0, this is where JZ end comes to play at the part of the instruction, and this considers the end of the program. So J and Z jump if not 0. This is just the opposite of what we saw. So if the label or the accumulator is not 0, then the condition specified to the jump is executed. So this instruction is typically used for implementing loops and conditional branches in a program. These are like conditional statements. So if you specify a condition along with the jump statements, then if the condition is satisfied, then it jumps to the specified location or it jumps to the part of the loop or jumps to the part of the program instruction where you have specified along with the jump. So this is the jump if not 0. My bad. So this is jump if not 0. You can see it is used at initialization, label definition, decrement accumulator, conditional jump, execution continues. As I said, in general, it's used for loops and conditional statements. See, similarly, this is for jump if not statements, as we've seen in the earlier jump if 0. So at first iteration A is equal to 0.5 and it decrements to 0.4 hex, and hex specifies for hexadecimal. So J and Z loop jumps back to loop. Since it is not equal to 0, it jumps back to loop. In this particular program, it is specified that if it is not equal to 0, then the loop should continue. You can do it with jump if 0 too, stating that if the specified label is equal to 0, then end it. Until then, the loop will run. Here it's the opposite. Until it's not equal to 0, the loop should continue. So until the fifth iteration, the accumulator is not equal to 0. And after the decrement, A is 0 hex. This is where the loop ends. So JZ and JNZ both are almost serve the same purpose. It's just how you want to use it. So that's it for this video. Thank you.